Welcome to the talk about Wikipedia and the lean data diet. And before we get started, to clarify, I work for the Wikimedia Foundation, which is the nonprofit behind Wikipedia's infrastructure. And I put here on the bottom right corner a couple ways in which you can contact me, or you can contact the people at the Wikimedia Foundation that work with analytics. And when I say the infrastructure for Wikipedia, this means that the Wikimedia Foundation maintains the servers, it administers the funds that you donate to Wikipedia, and pays engineers such as myself that work there. But the Wikimedia Foundation has nothing to do with the content of Wikipedia. And what we're going to talk about is about lean data, which is a concept that has gotten a name as of recent, but it's a practice that we've been doing at the Wikipedia Foundation for a while. And it's this idea that you should think very purposefully about the data that you're gathering from your users, how you are retaining it and aggregating it, and whether you really need it to provide the value that you think you're providing for your users. The good thing about giving a talk about Wikipedia is that everybody knows what it is. Probably everyone in the audience uses it. But something that matters for this talk that I don't think people are aware of is that Wikipedia exists within this larger theme that is the free knowledge movement. And of course, editors, when they come to edit Wikipedia, they embrace the ideas of the free knowledge movement and they put knowledge there for everyone to consume. But also when you're consuming Wikipedia, you're participating as part of this movement as a consumer, right? And why does this matter for this talk? Because the principles around privacy and data handling that we try to follow stem from the free knowledge movement. And the ideas are pretty intuitive. It's that you cannot really think of free knowledge without a guarantee of privacy. You shouldn't have to provide any information to participate in the free knowledge movement. There's no terms of service to access Wikipedia. And it's very hard for editors to provide knowledge without a guarantee of privacy and anonymity. But it's equally hard for consumers, right? Because not in all countries you can read Wikipedia freely. So we should strive to provide a guarantee so everybody can have access to free knowledge. And how is this guarantee of privacy expressed within the ecosystem or within the fact that Wikipedia is a website? The answer to this question is not very exciting and is through the privacy policy. But what is different about this privacy policy from other privacy policies that you may have signed when we were all getting tons of emails about GDPR is that the privacy policy for Wikipedia was built the wiki way, the same way that content is built. So it was built with a larger community that cares about content and cares about the free knowledge movement. And the discussions to come up with the text of the privacy policy were this long, 150,000 words. And for everyone to get a picture here, this is as thick as a volume for the Lord of the Rings, right? So there was a lot of discussion that went into creating this policy that exemplifies the principles around privacy and the movement. So what are the things the privacy policy talks about? You should be able, like we said before, you should be able to read Wikipedia without providing any information. The Wikimedia Foundation, as the entity that administers the data, is not going to sell your information to third parties and it's not going to share it with third parties. And when it comes to data aggregation, after 90 days, most of the granular records are either deleted or aggregated or de-identified. And it's larger. This last point is probably the hardest one to explain. So the privacy policy, like these principles, have like a strong implications of how do we do engineering, right? It's not just a matter of like a philosophical thing, but there's a strong implications. And perhaps the biggest one, when we think about never selling and sharing your info with third parties, the implication here is that Wikipedia runs on premise, right? So when we're talking about data for Wikipedia, this is not data on any cloud, but rather is data on our data centers, which this is a picture of that our DC Ops engineers manage. And we have a GitHub repo that is public, where you can see how all the software is deployed. But what we're going to talk about here more rather than the whole ecosystem of deployment, which is affected by these privacy practices, is about the data itself, what happens with it, right? We try to compute metrics in a privacy conscious manner. We release a lot of data. We're releasing publicly data every hour that is used all over the world. And we actually have to delete a lot of data. So I'm gonna talk about the data deletion, what we call sanitizing data, and the most important of all, which is building a privacy culture. And this is the hardest to do by far. So deleting data is something that seems easy until you have to do it at a scale. And there was one of the presenters at this conference, I don't know if it was last year or the year before, wrote a paper about how hard it is to delete data in large systems, because for starters, your data is probably going to be in two systems. It's in Hadoop, but it's also in Cassandra. It's in Cassandra, but it's also on Ruiz. So when you need to delete data, you need to think about this idea that you're deleting it from the primary source, but also from a bunch of secondary sources. And the data we're talking about here is this. I'm going to move my video a little bit so you can see what this is. Usage data called web requests, which is what you get as part of an HTTP payload, right? The project you're looking, Spanish Wikipedia, an IP address, a user agent, and a page that you're looking at. But also, we're talking here about behavioral data. And behavioral data is like you click on a button or you click on a menu, and those two types of data are subjected to data deletion and aggregation and sanitization. But we're talking here about deletion. So how big are our data sets? So at peak, Wikipedia gets about 200,000 requests per second. These are requests, not page views, which is a lot. You can see here in the graph our peaks of traffic, where with I would say, the beginning of the pandemic as it spread across Europe and the United States at the beginning of March. And you can see how we have very large peaks of traffic here on the beginning of May. For behavioral data, like click-throughs and usage of features, the web volume is a lot smaller, 1,000 times smaller, and about 2,000 events per second. So the first thing that we want to think about when we're talking about data deletion is that you have to be very safe, because mistakes in data deletion are hard to unmake, sometimes impossible to unmake. So I want to share like a quick tip here that we have that has come to help us a lot. And I try to exemplify in these talks the do nots with like the red and the do's with the green, right? Like important for when you're talking about deletion, that any default arguments of your scripts don't do anything that you will regret. So if you have a default argument that is tables to delete, if the argument is not present, the default should never be delete all tables, but rather delete no tables, right? So a solution that we have in order to make as little mistakes as possible when scheduling cron, so scheduling things on Puppet for data deletion, cron, systemd timers, we have a script that has a set of arguments that you would have here on the command line, like database event, tables, menu click, wikis, blah, 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 delete data that is older than 90 days. And when you execute this script, you first have to execute it on dry run mode, right? And the dry run mode is gonna give you a checksum. That is a checksum for your parameters. So whenever you schedule it and you put it on your templates that Puppet is later gonna execute, you need to pass that checksum. So if you make a mistake in one of your parameters, and instead of saying older than 90 days, you say older than 9 days, hopefully you don't end up deleting like a lot of data that you didn't intend to delete. In this case, what it will happen is that the script will not execute because the parameters don't match the checksum. And this is like a very low-tech solution, but I find like solutions of this nature that are very simple work well forever. So I quite like this idea. That I didn't come up with it, somebody from my team came up with it. But of course, we don't delete all data. We also sanitize a bunch of the data. And what we call sanitization is a technique in which we try to remove the most identifying pieces, and hopefully the data that persists is a very non-identifying data set. But of course, the notion of identification carries a notion of risk. It's never like 100% safe procedure as deleting data would be. And for that, I wanted to give a super fast overview of what the data pipelines look, which is very standard. For behavioral data, you have the clients, could be a mobile phone or your desktop. And the data comes into a beacon that is located in Varnish, because everything in Wikipedia goes through Varnish through the caching layer, because most of our requests are served cache. From Varnish, you move into Kafka, the request dispatcher, and after to HDFS. And what we decided to do here in order to sanitize data was not sanitize data that we're ingesting, but rather ingest data into a data store that every 90 days gets purged. Every day is getting purged, actually, and is deleting data that is 90 days older. And at the same time, the data stream is moved through an allow list here and this allow list tells you what is going to be persisted for longer than 90 days. And all this data and the allow list are public, and you can see them in GitHub. So why do we use an allow list? If the data looks like this, IP, user agent, the wiki, and the action that was taken, like clicking, if you have a do not allow list, what happens is that, and let me move the video again a little bit higher here. Perhaps I will move it lower. So with the do not allow list, the IP is being sanitized to a null value, and so is the user agent, right? But what happens when you get an extra field with a do not allow list? You end up having the identifier because you didn't explicitly remove it. Whereas if you have an allow list, you nullify the fields that you were interested on, the IP and the user agent, and for the cookie, you will nullify it, right? Because it's not on your allow list. Another technique that we use to de-identify data is bucketizing it, right? So rather than nullifying the ID, I keep like a very granular piece of data about it. This IP is in Spain. And rather than nullifying the user agent, big bucket, this is a Linux user agent. And rather than nullifying the cookie, I may hash it with a salt that is changed, for example, daily. So you will actually be able to link together the records for one day. And of course, this has a potential for identification, but you will not be able to link this cookie with the cookie for the next day, right? Important, just as important as technical mechanisms to delete data is to build a privacy culture. And I think the idea here is not very different from performance. Like I worked on a performance team years ago, and many times I felt like I was the performance janitor because you were left with like a bunch of problems that you had to fix, right? Ideally, performance would be a culture that we built in from the beginning, and privacy is the same. It shouldn't be the responsibility of one team, but rather of the organization. And I want to provide an example here of metrics that just take into account privacy from the start. And the one I wanted to talk about, and let me move the video again. I will move it on the up here again, is about how you compute the what is like a very web standard metric: daily active users or monthly active users. Because we're talking about Wikipedia and you don't need to be logged in to use it, these are not users, but they are devices, right? As understood as browsers, really. So anywhere where you've computed this metric before, what you use is a token, a unique identifier that identifies your device. And what you do is like, you do a request and tag the identifier along. And if the identifier lives for 30 days, you just need to count the distinct identifiers that you have for that time period. And you know how many unique devices did you have, right? The problem with this approach is that something we want to guard against it is precisely that idea that you can build a browsing session that tells you every article that a device was looking at for 30 days, right? Like if we have like an external entity, like a government that asks us for data to surrender the records for a particular device, or for everyone that has looked at a particular page, we don't want to have that data. We don't want to be able to link it together. So using unique identifiers will make that very easy, in fact. So we came up with like a different technique to do the same thing that is equally precise. And I put a link down there where this is explained on more detail. And we call it the last access. So if you go to Wikipedia right now, you will see that a cookie is set, which is the last time that you access Wikipedia. So say this person here, last time they went to Wikipedia was the 1st of September. So they have a cookie in their device that is gonna last for 30 days. That is, it says 1st of September. And today comes around. And today is the 15th of October. And this person goes to Wikipedia again because they wanna look up something. So their request is gonna include the value of the cookie, which is the 1st of September. So I store the last access cookie together with the request. So when you look at the logs, things are gonna look similar to what you see here. The date of today is the 15th of October for some IP. Somebody was looking at the page Titanic, and the value of the last access cookie was the 1st of September. Because of the way HTTP and the web work, when the response comes back, I'm going to update that cookie. And now it's been updated to the 15th of October. This is what the user has on their computer. So when they do a subsequent request today, they send me the new cookie, right? They send to the storage the new cookie. So if we look at our logs, they will look like this. For the first access, the cookie had the value of the 9th of September. The second time is the 15th of October, the day of today. So how with this data I can calculate the unique devices? So what I need to do is to see all the records that have an access date that is prior to the date of today, or the access date is null, right? Like I don't need both records. With the first one, I can note that there was like a unique access at this time, right? There was a device that was their first hit today. The subsequent requests are of no importance. And this method, while less intuitive, is equally precise that it would be like a token method, right? Like it works the same, but it has the advantage that it doesn't give you a piece of additional information to join these records. In this case, this customer is accessing, or this reader is accessing through the same IP. So sure, I could join these two records, but you could see how it could be a mobile phone and you have changed Wi-Fi networks. So then these two records would be unlinkable, right? Like the cookie doesn't help me to link a browser session, but it's a piece of information that just helps me to do the calculation I want to do. So to wrap up, for the lean data diet, there is some cons and there's some pros. And for the cons, clearly it's more work. I mean, computing unique devices the way I just explained is more complicated than computing unique devices with tokens. Let's be clear that it's no less precise, but it could be that for some metrics, you have to work with proxies that are less precise than the metrics themselves. So that could also happen. And building this privacy culture takes a lot of time. You know, in the foundation, we're committed to privacy, but building this awareness takes a lot of time. You're going to hire people from other organizations that may have a theoretical commitment, but when it comes to the reality of the practice, they may not be so familiar with what they need to do. And the data analysis certainly needs a different mindset, because in instances, you're going to have to look for workarounds. Now, the pros are significant. When it comes to data requests, there's a lot less work. And it's much easier once you have aggregated and deleted your data, make data public, right? Because the data that remains is much more shareable than it would be otherwise. And also you can truly offer a guarantee of privacy, right? And this is important because at the end, for Wikipedia, privacy is a hidden feature. It's something that we offer that you don't really see, but it's as much part of Wikipedia as the content itself, right? That's like an important idea. And I think this is my last slide. Yes. So opening for questions now. Thank you, everybody.